Yeah, you're watching Vestigial Full Amazon product review of the Hoberman Sphere. Now, this product gets 5 stars easily. Look at this thing. There's so much you can do with it. Look at the complexity of all those hinges. It's like a bunch of hinges opening up to open up a bunch of doors and pour out cream. Can wear it as a space helmet. I'm a time traveler. I'm interdimensional. Went into the 5th dimension. It's my space helmet. Yeah. You can wear it as a helmet or wear it as a bracelet. You're like this. This is more valuable than a diamond bracelet. Or you can even wear it on your computer, for crying out loud. This Hoberman Sphere is awesome. Can set up a trampoline type of contraption here and try to bounce balls and apples through it. See how I do it? 1 point. 1 point. No points. See how you can do. Try this. How many can you get through? There was a challenge given by the creators of this Hoberman Sphere, and they asked, how many pieces make up this contraption? I know the answer, or at least part of it. Now, you might want to pause the video before I reveal it. Okay, well, out of each of these circular colored rings here, I calculated that there was 360 pieces that make up each of those rings, and there's all these blue pieces all around here that make it up, and I couldn't count how many of them there are. I know that there's 2 for each pair, but I estimate that there's 30 of them, so 30 times 2 would be 60, so I estimate that there is 360 pieces out of these rings plus the 60 for each blue pair, so an answer of 420 pieces. Alright, well, I wanted to talk about the views on objects and the angle on which you view things, and I figured that this Hoberman Sphere here was a good way to demonstrate it. Now when you're looking at an object, there's 2 factors that determine the angle on which you're viewing it at, or the angle on which it's at. You start off with one axis, and you can rotate your way around that axis to a certain number of degrees. So that's the factor 1 that determines the angle on which you view it at, and then you can go 90 degrees from that axis to an axis like this, and then you figure out how many degrees you want to rotate it to look at it on that axis. You combine those 2 factors together, and that will give you the angle on which you're viewing something, or it's rotated at. This can apply to the way that you're looking around at something, or it can apply to the way an object is rotated. And now, the number of angles there are for each of those factors is infinite, because there's an infinite number of angles, so you times an infinite number of possibilities for each factor, and that gives you an infinite number of combinations, which means there's an infinite number of ways to look at an object, and each of those ways or combinations will have the factors varied to a certain extent, and it'll each be a certain way to look on the object. As you can see with this Hoberman Sphere here, each of these rings around it are rotated a certain number of degrees on a plane like this way, and then they're rotated a certain amount this way to give them the angle on which they're being viewed at. And I can better demonstrate this on a CAD software if some kind of Photoshop or CAD software, like, you know those two circles that are rotated 90 degrees from each other? That's the same exact thing of what I'm talking about here. It's just, you combine those two factors together to get the angle that you're viewing it at. Yeah, release the boulder. Sphere can be dropped onto the ground, and it is in perfect condition. It's nice and strong. All those points come together to make it strong, but you don't want to drop it while it's closed like this. When it's like this, it's kind of hard and it'll break, but open like this, it's kind of pliable and it won't break. I've added this string on here, which is preventing it from being closed. This sphere cannot be closed because that string right there is preventing the hinges from extending outwards there. Well, if I pressed hard enough on it, it would, but it'd break the string.